I'm very glad to be here after such a long period of not being able to do this. Again, giving some live presentations and meeting people face to face is really exciting. So I'll be talking today about printed electronics, what we do in that as Henkel, and also what it can do, and then more specifically towards generating some new data-driven solutions and applications. So at Henkel, and Henkel also has its headquarters here in Düsseldorf, so very close by here, we have our headquarters. We have been doing printed electronics already for many years, so 40 years, even more, I think. We have been active supplying all kinds of functional inks to make printed electronic components. So, if we talk about printed electronics, and the very basics is actually that it's not the traditional electronics like you see here on the right side with the traditional green PCB board. This is what is used in most of our phones, cars, everything. This is not what printed electronics is. Printed electronics is basically simplified electronic circuits on a flexible foil usually. And that's where the main applications are. It's again a printing technology, so an additive technology that applies the functional material on a flexible foil so that it can be very light, it can be very large, it can be stretchable even, and certainly flexible. So just that you guys know, it's not about the traditional electronics, and there is no way that with printed electronics we can actually reach the same complexity and same functionalities as with traditional electronics. So what do you need for printed electronics? Obviously you need an ink. That's where we come in from Henkel. So we have about 100 different functional ink materials that can be applied. And today usually that is still screen printing. The ink on the left side here, it has a certain functionality, meaning that there can be real silver particles inside, there can be carbon or graphite particles inside, there can be silver chloride inside, or there can be other type of fillers inside to give it some dielectric functions. And with the combination of these materials, this allows to make simplified electronic structures by a printing process. So people, printing companies, they use our inks. They apply them on the foil by, as I said, usually a screen printing process. After that, then the devices are singulated, and devices like you see here on the right side are the traditional devices that have been made using printed electronics. So for example, glucose testing strips for people with diabetes, seat heaters in cars, but also other heating systems, electrodes on the skin, and also these membrane switches are well-known examples of printed electronics. So this is typically how the value chain works. It's quite simple: ink, printing, device singulation. Now, we at Henkel, we focus on three major areas for this printed electronics. What I showed in the previous slide was actually the traditional applications. We see that there are also now opportunities opening up for new applications. On the one side, in healthcare applications, we see a lot of opportunity. So there are opportunities where you stick something like a sticker to the skin that measures then some vital parameter of the body. The same is for wound care here. For example, here, this one, where you integrate sensing functionality in a wound dressing to measure how well the wound is healing. And then the most, I wouldn't call it simple, but the one which is now also coming to the market is a smart diaper, where actually a sensor is integrated into the diaper, and then primarily for elderly care to monitor the saturation level of the diaper. So these are the applications we work on in healthcare. Next to that, second priority are antenna materials, all kinds of antenna materials, going from 5G antenna to Bluetooth antenna. There are many more antennas that are currently printed, even in the smartphone. There are 5G antennas now PET printed using these silver-filled materials. So also that is a strategic area for us in terms of antenna. And then the third one has actually to do with smart surfaces. So how can we make, using printed electronics, everyday surfaces smart? I think we are all very well aware of automotive, the whole electrification of the car. Again, there are many options moving forward. You see already now with Tesla, just has one screen, but there will be other functionalities that are also integrated and in the dashboard or in the ceiling of the car that printed electronics allows. So those are the automotive applications. There are also more industrial applications where we look at sensors that can be easily integrated to monitor leakages or other things. So these are our three strategic priorities. Two of those, specifically the healthcare one and the smart surface, actually take it one step further to more, as you see, there is a lot of data things added here. Antenna, of course, that communicates the data, but the antenna itself is not part of the data stream. So the way that we see it at Henkel is more that printed electronics is a key enabler for those new applications. It's a key building block, but by no means it's the only building block, and I come to that later. So it means that printed electronics can be just the top of the iceberg and can be one of the building blocks to enable all of these IoT things, printed electronics, to make that happen. We see that specifically in our focus area, so in healthcare, but if we look to smart surfaces here, we all know and we have heard about smart cities, smart living, smart mobility, even smart agriculture. All of these applications, they require a lot of sensors that actually result in data so that the processes, that our lives can be made easier, our electricity consumption can be optimized, for example, all kinds of different things. And in some of these, printed electronics can play a role. One key to realize is also that traditional industries are also moving to a much more data-driven approach, where the end user is really at the center and connects all the dots together. I think there is a fundamental shift also happening when we move to more data-driven business models as well. We see that innovation time becomes much more important and needs to speed up to be able to be successful. Technology requirements are increasing, and also cross-industry know-how and partnerships are really crucial for success. So moving from the traditional way of the industry to a more all-connected way is also super important to realize if you want to be successful in this area. Then if we talk about printed electronics and we talk about connected applications, the value chain actually gets a bit more complicated. So still we start with an ink and a substrate on the left. At the end here on the right side, we have an application. In this case, it's a health patch that is attached to the body. But in between, there are now also some hardware electronics that needs to be added. And there is also integration and the connection to the cloud and the algorithms that need to be there. So these three building blocks are actually new. And it's very important to realize that any of those are very important. And that is why we also specifically at Henkel, we put a lot of emphasis at developing the whole ecosystem for that, all with the goal to allow our end customer here that wants to bring a product to market to speed up. So from a Henkel side, we don't do all these things in the middle. We are not specialists in that, but we do have dedicated partners to do all of that. So if we have a new application, and then certainly in our strategic focus, really the end customers to realize their application. So the key is partnerships in this whole story. Then let's move to some real examples to show you how we do that and how printed electronics is used in these areas. I'll show a couple of examples here in the healthcare space on the left, talking about these smart diapers that I referenced, and also the remote patient monitoring. And then also more on the industrial side, the leakage detection. All of those actually use printed electronic sensors. So let's start with health patches. Health patches, simply said, these are stickers that you attach to the body to measure some vital parameter of the body. They have 4 main use cases at this moment, the main one being cardiovascular monitoring. So people monitoring the heart over a longer period of time. This can be done with such a technology. At the same level, then a cardiologist can do that in his practice. 3 other applications are monitoring fetal, so babies still in the belly, wound care, as I mentioned, and also sleep monitoring can all be done with a similar technology, a similar health patch technology that measures certain parameters of the body. One of the examples that we did in Belgium 2 years ago now is called COVID at home. So this was really to use, can we use the technology that you see here on the screen? So this is the real device here to monitor people with COVID. And the reason for doing that was, okay, we want to release a bit the burden on the hospitals, certainly during the COVID peaks, so that at the end of the disease, when you are almost recovered, you could actually already exit the hospital and recover further at your home, but still the doctors and the caregivers could monitor you using this device. So basically this means that you go home, this was put on your chest, and you were monitored, returned, and it got worse again, you could also come back to the hospital. And this has now been rolled out to over, I think, 30 hospitals, specifically in Belgium, that actually have used this technology for COVID. This is just one example. I think this is where COVID also accelerated the whole adoption of this technology. But now also cardiologists are familiar with these technologies, and they are now starting to use this also more for their standard analysis. In the end, it all comes down to having the right technology to measure something, to yield very high-end data that somebody can use or an algorithm can use to do some calculations with basically patient centricity. So that means that the patient is in the center, needs to be individualized in terms of response that it gives and the treatment that the patient gets. It needs to be really individualized for the individual patient. So where does printed electronics come in? So this comes into the sticker that you just saw glued to the chest. This is actually made out of a layered structure shown here, starting from a flexible foil, a TPU foil, on which the different electrode levels are built. And you see here, we from Henkel, we supply 6 different materials in that layered structure, going from a skin adhesive on the top to a dry electrode, protection materials, silver stretchable inks, and also the laminating adhesive to bond it to a textile. So this is how the printed electronics is integrated into those stretchable stickers that go on the skin in this type of application. Some of the materials, just to highlight a couple that are key for the success here, are a stretchable silver ink. So we have developed a material that you can stretch and then also returns to the same resistance level if the stretching is released. You can imagine that if you put such a device on the skin and you start breathing, your chest will continuously expand and contract, meaning that you need some level of stretchability. You don't need 200% of stretching, that's not what this is designed for, but you do need 10 to 20% levels. And these type of materials can actually, but they return to the original level when the stretching is released. That's one key material. Another key material is the dry electrode material. So this is basically a skin adhesive that functions as a hydrogel. Why have we developed that? This was also a key enabler because it allows to wear those stickers for a longer period of time. Up to even a week or even 2 weeks, continuous if you want, you can wear the sticker and it can continue to measure. With traditional electrodes, that is not possible because they are using a hydrogel. The hydrogel will gradually dry out and the signal quality goes down after maximum 48 hours. That no longer happens with this technology. So this is really instrumental to allow long-term monitoring. So that was the health patch. Then zooming into the smart diaper. This application is also adding a lot of value for the patient. So for the, in this case, mainly the elderly people in the nursing homes. In a very simple way, and you can see it here. This is the smart diaper. What happened actually is that a smart sensor has been printed onto the diaper substrate at the outside. So you see those 3 black lines. Those are forming a capacitive or 2 capacitive sensors. There is a small electronic clip-on that you need to clip on the diaper, and this then communicates to the cloud. And in this way, you can change the diaper when it really needs to be changed. So today, most people in elderly homes, they are changed 3, hopefully 4 times a day. That's just the way it is, every so many hours. With this technology, it's actually becoming smart, and people and nurses can monitor people and change when the diaper is, for example, 70% full, so that the comfort for the patient increases, but also the effectiveness of the nursing staff can be increased. And thirdly, very important as well, by using this technology, it allows to use about 20 to 25% less diapers because they are only changed when they need to be changed. This is how the system looks. So just to show it, 3 black lines printed on the back sheet before the diaper is produced. Then these lines just undergo the traditional diaper process to the diaper to make it smart. And then can either be connected to a phone or to an infrastructure. So again, this is the value chain for that whole process. And here we also didn't do this alone as Henkel. We have partnered here with a company called Smarts, who actually have the patents around this technology. They have the hardware electronics, and they also have the software algorithms to do that analysis. Because this device, the smart diaper, it doesn't say just, hey, the diaper is wet or not. It can really say, hey, the diaper is 60% full or 65% full. Meaning that it becomes truly a smart device. There is an algorithm behind it that can monitor or that can calculate the saturation level of the diaper. So again, here, partnership is extremely important, both in the initial phases, so in the printing of these devices, and these materials, they are printed using a minute. These conductive lines are printed onto a backsheet foil of around 10 to 15 micron thick. And then that they undergo the same production process as a standard diaper. Nothing is different in that respect. The key material for this is the black material to yield the capacitive sensor. This is the material that we developed for that. As I mentioned, this can be rotogravure or flexo-printed at very high speeds, yielding a very thin layer on the backsheet of around 1, maximum 2 microns usually, and still have a very good electrical conductivity to allow the capacitant function to work. So those were the healthcare applications. Then to end with a few slides on what we are doing with more industrial applications. So also here for detecting leakages, it's a bit similar like the diaper, but then a different application, right? You look in industrial applications for leakages. In essence, the technology is very similar. The connecting technology is a bit different, but the sensor itself is very similar, and also similar materials can be used to make the sensor. If there is water then in contact with the sensor, there will be an alarm so that an action can be taken. How does this work? It's, again, very simple. You have a printed sensor. This can be screen printed, can be other printing technologies. In essence, a resistive sensor or a capacitive sensor. That is connected with some hardware electronics. The hardware electronics contains the battery and also communicates the data to the cloud. And then basically there is a software tool that does a certain action. So very simple setup, but again, it needs different competences. So you need an ink, you need to print it, you need hardware electronics and the software. So again, showing why these partnerships are very critical. Key examples of this are, for example, wooden floors in sport areas, or doesn't matter where. If there is water leakages, this can create significant damage and a significant cost. So these things are rolled out in different applications for pipes, underneath these things, underneath different things that contain water where leakages happen, to actually signal it early on. And the nice thing is that with these printed electronics, because it's very thin, you can actually integrate it seamlessly into a very small area. And this is then also one of the examples of leakage detection, but there are, of course, other types of sensors that you can build with printed electronics as well. So I hope that I've shown you that printed electronics has been around for many years in the traditional applications. There are a few emerging applications that I've shown here in healthcare and smart surfaces. From a Henkel side, we supply key building blocks in the material to make that happen, but also in the middle there, as I mentioned repeatedly, the ecosystem and the whole partnerships are really crucial if we want to progress this to a next stage. So in the end, the materials and printed electronics in general are key enablers to allow new data-driven business models, particularly in healthcare and smart surfaces. So thank you. And if you have an interest in also these materials, or if you want to get in contact, you can do that through this website. We have an e-shop where you can buy also sample quantities, but of course you can also get there in contact with us to get more information. Thank you very much.